This short recording is going to go through the process of calculating reaction forces, which is the first step of your truss analysis. So a couple of quick things. We've just got a truss over here that's got two forces, one of 20 newtons and one of 30 newtons, and they are spaced 1 meters, 2 meters and 1 meter apart. Notice first of all I've got two different types of reaction forces. I've got the reaction force A and B. This one is a fixed support, which will have both a vertical and a horizontal, and this is a rolling support, which only has a vertical reaction. In this question though, we only have vertical forces, so we don't need to worry about that. So the way that we always start these questions is we always start with a fixed support because it's got two forces, and we take our moments around that particular fixed support point P. So what we're going to do is say the sum of the moments around that point in a clockwise positive direction must equal 0. And what we're doing over here is we're going to try and figure out what are the forces trying to spin this bridge, which will effectively give us what this reaction force at B is. And so what we do is we say that is equal to, the first moment is a force times a perpendicular distance of 1 meter. So it's downwards, so that means it's clockwise, so it's a positive of 20 multiplied by 1 meter from point P. The next one is also a positive clockwise of 30 multiplied by 3 meters. And the last one is our reaction force B, which is anti-clockwise because it's trying to keep the bridge up. So it's RB multiplied by the full length of the bridge, which is 4 meters. So what we'll find is that 0 equals 20 plus 90 minus RB times 4. If we move all our sums around, RB times 4 equals 110 newtons. And so RB is equal to 110 divided by 4, which, if you do a calculator, 110 divided by 4, 27.5 newtons. So that is the force over here reacting is 27.5 newtons. Now what we could do is we could put a moment point here and do the exact same thing backwards to calculate what the reaction force is at A. But if we look at this carefully, we'll realize that we can use a different kind of calculation. Instead of using moments, which are turning forces, we can use some are vertical and some are horizontal forces. Remember that the sum of the forces in the vertical must equal 0, and the sum of the forces in the horizontal must equal 0 for this particular bridge to be stationary. Otherwise the bridge would be moving up or down or left or right. And so if that's the case, and we've only got vertical forces, we can say that the sum of the forces in the vertical must all equal 0, which means that the reaction at A, which is positive, minus the 20, which is negative because it's down, minus 30, not 30, yes 30, which is that force down, plus the reaction at B, because we know that that's a positive reaction, must all equal 0. So RA is equal to, and I'm just going to change these, 20 plus 30 minus RB. What I've done here is I've just moved RA over this side, or I've just moved all these onto that side of the equal sign, and when you do that you need to change the signs in front of them. And so what we see is that RB, because RB is equal to 27.5 newtons, we can say RA is equal to 20 plus 30 minus 27.5 newtons. And let's do that in our calculator. 20 plus 30 is 50, minus 27.5 equals 22.5 newtons. So what we see here is that the reaction force over here is 22.5 newtons. This is kind of consistent with your understanding. If you've got more force here, you probably have a bigger force there, and less force here, you probably have slightly less reaction force here. But you can see what I've done is I've used two different methods. Here I'm using moments, here I'm using some of my forces vertical, to calculate the two reaction forces